Montessori Grandma.
I told you, Mia, you can't blow it.
Why? You think only you can blow it?
Oh yeah, I'm big and I can do many things and I know many things.
I do know many things.
You know nothing. Zero. Haha. But don't worry, Mia. You always have your big brother to help you out in difficult situations. Watch this.
Oh yes, the big brother who knows nothing. Zero.
I know nothing. I know many things. Much more than you anyway.
Like what? You know nothing.
Like, for example, do you know how this house looked like when we moved in? See, you know nothing. When we saw this house for the first time, there was nothing inside the house. Just these walls and the roof. Nothing else.
Nothing else?
Nothing else.
You're right, Milan. But do you know what it looked like when I saw this place for the first time?
Grandma!
Hello, kids. Tell me, when I saw this place for the first time, do you know what it looked like? When I saw this place for the very first time, there was nothing at all. No buildings, no parks, no cars, nothing. Just some trees and this river.
Why are you both always saying there was nothing at all? There was always something, right? Like birds, sun, air. There is nothing like nothing, right? There is always something.
You are right, my little girl. But there is something about nothing. Like it was when
It was when?
Like it was when the universe came into being. There was nothing at that point of time when it all began.
No trees and birds too?
No trees and birds.
No dad and mom too?
No. No dads and mums. No granddads and grandmoms either. In fact, there were no people at all. No cities, no animals, no stars, no mountains, no rivers, no oceans, nothing at all. Even our planet Earth was not there. There was only the great space, which had no beginning and no end. It was dark and cold. So, in the beginning, it was all dark and cold.
Cold, like now. I'm shivering already.
You think this is cold? This is nothing. I've heard that it was so cold that there was ice all over the earth.
Yes, but it was much colder than that too.
Colder than ice? How?
Let me show you. Milan, could you please bring the 2 bowls of ice from the freezer? Mia, let's get 2 thermometers. Let's do an experiment. That's how you'll see just what I meant.
Oh, yes. I get to do something fun.
Oh yeah, and I get to know something cool.
Yes, cause when you do it,
You get to know it.
okay, now why don't each of you measure the temperature of each bowl? See, -2 degrees is colder than 0 and -20 is colder than -2. It can go even lower.
Lower? So, -100 is possible?
Yes,
-200?
yes, of course, it's possible, but it will be unimaginably cold. No one would survive.
Grandma, let's send Millen to -200. Let's see how Mr. I Know Everything will survive there.
-200 is too much for Milan. But what would you carry with you if you were sent to such a cold and dark place, Milan?
Aha! I will carry this light like this, and I will walk forward slowly.
You brave boy. You are right, Milan. In such a situation, a light would help us. It would give us relief from the cold as well as the dark.
So they had candles. Who made the candles that long ago, Grandma?
There was no one, remember? This light was some kind of force or energy that suddenly came into being, that shone very brightly and was very hot.
But where did this come from?
That's the magic of nature. It's like an instant cloud of force with great energy. They say that the entire universe was in that cloud of energy. The stars, the sky, the materials that we see around us, all were in that cloud of energy. Since all the stars were combined, it was so bright and hot.
But what did it look like, and how did it come all of a sudden?
Let's see if there is a picture to give us a better idea. The whole universe was in a cloud, and amongst the tiniest of stars was our own sun. They were not stars then, but just light and heat. There was now light, light greater than we can imagine. So intense was the heat that all matter, iron, gold, rock, water, existed as a gas. They were all fused together in one vast, flaming intensity of light and heat. Heat which would make our sun today feel like a piece of ice. The raging fiery cloud of nothingness, too huge to imagine, moved in the immensity of freezing space, which was also nothingness, but infinitely more vast. The fiery mass was no bigger than a drop of water in that ocean of space. But that drop contained the earth and all the stars, which are really blazing suns, millions of times bigger than the earth. As this cloud of light and heat moved through empty space, little drops fell from it. As if when you fling some water out of a glass, some of it stays together and the rest breaks up into little drops. The countless stars are like the droplets of water flung from the glass. Only they have now spread out so that they are millions of miles apart and go around one another in space without meeting.
Grandma, looks like Mia needs some instant energy to warm up. She's almost sleeping off.
Is that so, Mia?
No, Grandma, I'm not sleepy. But yes, I need something to drink.
Oh, I forgot. Your mom already made some juice for us.
I want some more.
Oh, but there is nothing left.
Well, not quite. There is something there, right, Grandma?
What do you mean, Milan?
Grandma, there's air there.
That's funny. But yes, you're right. There is air. That's good thinking, Milan.
See, Mia, I know what nothing is.
Mia, we'll all have something a little later. Right, Milan? Mia, do you remember the cloud of nothingness?
Yes?
Well, that too had all these things. Just like the juice jar has juice, which is liquid. And see the small grains of the fruit in the jar? Those are the solids. So the cloud had all these: solid, liquid, and gas in it.
I know what this is. This is the 3 states of matter.
That's right. To get a better idea of how it looked, let's try a small experiment, shall we?
Oh,
yes.
Let's do an experiment. That's how you'll see just what I meant.
Oh, yes. I get to do something fun.
Oh yeah, and I get to know something cool.
Yes, 'cause when you do it,
You get to know it.
Take a balloon filled with paper pieces. Once you have filled the paper pieces inside the balloon, blow up the balloon until it bursts. The paper pieces fall into the water. You can see that some of the pieces cling together, while some pieces do not cling together.
Okay, so it was like this. The cloud of energy must have burst into many little bits.
So it all happened in a second?
no, it's much, much faster than a second. And we need a different way to measure the speed. Let's look into the book. Indeed, they're so far away that it takes the light of some of them millions of years to reach us. Do you know how fast light travels? 100 kilometers? 200 kilometers? 1,000 kilometers an hour? No, much faster. It travels 300,000 kilometers. That is 186,000 miles. Not per hour, but per second. Imagine how fast that is. It means that in 1 second, light can travel 7 times round the earth. And do you know how big the earth is? 40,235 kilometers in circumference. That is 25,000 miles in circumference. If we were to drive at 160 kilometers or 100 miles an hour continuously, all day and all night, without stopping, it would take us more than 10 days to cover that distance. And yet, light covers that distance 7 times in 1 second. You do click with your fingers, and light has traveled around the earth 7 times already.
That sounds really fast.
Yes, in fact, we can try to get an idea how fast it is.
Grandma, you're making me frightened with all these stories. That is why she is coming closer to you.
No, Milan, she is not afraid. In fact, she's coming close to me because she loves her grandma so much. Right, Mia?
Yes, I'm not afraid, but I love my grandmother.
I also love you too, Grandma.
Now, this reminds me about particles and their behavior.
The particles that formed from the instant energy?
Yes, let me show you some experiments. Particles are also like humans. They will cling to whom they like, and they will move away from those who they don't like. Let's do an experiment. That's how you'll see just what I meant.
Oh yes, I get to do something fun.
Oh yeah, and I get to know something cool.
Yes, 'cause when you do it,
You get to know it.
Quality and property of liquids. Let's take sugar, glass and stirrer, and sulfuric acid. Take 1.5 tablespoons of sugar into the glass. Then add a little of the acid to it, just enough to cover the sugar. Stir well with the ceramic spoon. The sugar starts to turn yellow. And finally, it turns black and smoke comes out. The smoke stops and a large piece of coal is left in the jar. Particles of solid and particles of liquid join together to form a new substance. Particles that do not love each other. We need chalk powder, a test tube, and water. Take some chalk powder and put it into the test tube. Add some water to it. Stir it well. The water turns white. Do you think the solid has dissolved in the liquid? We can see that the solid loves the liquid. Let's keep it for some time. Actually, they don't mix together. Particles that do not love each other. We need a white cotton cloth, magnet, plate with sand and iron filings, and a spoon. Mix the sand and iron filings. Place the magnet on the top of the cloth. Move the cloth above the plate containing the solids. The iron filings stick to the cloth and the sand remains in the plate. Some solids may not mix together.
I have some friends like particles. Sometimes they will fight with me, and sometimes they are friends. Sometimes we form groups, all particle friends.
I too have particle friends. We form shapes by holding hands.
You children understand it very well. Like your particle friends, our particles also started forming shapes. Let's see in the book again. When the fiery cloud broke up into droplets that would become stars, all the details had been planned. Every scrap of the universe, every speck of nothingness, which we can't even see, mattered a great deal and was given a set of rules to follow. To the little particles which are like smoke, like vapor, the rule was, as you become cold, you will get closer together and become smaller. So as the hot fiery particles cooled, they moved more and more slowly, clinging closer and closer together, taking up less and less space. As the particles of the fiery cloud slowed down, some cooled down more than others, and depending on how hot or cold each particle is, it became a solid, a liquid, or a gas. Everything in the universe is in one of these states. Some particles were attracted towards others, and some were not, just like human beings who like some things and dislike others. In this way, the particles combined and formed different groups. The different instructions given to each different type of particle was: to the solids, you shall cling closely together. You will stay still and not move unless you are pushed, so that they don't change their shape unless a physical force breaks them. And if they become broken and a part chips off, then you end up with a few solid pieces. The different instructions given to the liquids was: you shall hold together also, but not so closely. You won't have any shape of your own. You will flow and spread, filling every hollow and every crevice you reach. You will always push downwards and sideways, but never upwards. That is why we can put our hands into water, but we cannot plunge them into rocks. You will always want to move, always rolling over each other. And to the gases, the rule was your particles will not cling together at all, but will move freely, spreading out in all directions. But as the particles were also different individuals, they did not all become solids, liquids or gases at the same time, but changed at different temperatures. So, at a certain temperature, some would remain solids, others would be liquids, and others would become gaseous. And so, while obeying these laws, the little drop of nothingness that was to become our world went on spinning round itself and the sun in the tremendous cold of space. As the time went on, the outer surface of the earth began to dance, a dance of the elements. The particles above the earth were cooled by all the icy space. But when particles cool, they shrink and hurry to the earth to warm themselves. But then the burning fire inside the earth would heat them up so much that they were too hot and longed to be cool again. So they went back into space. Like little angels carrying up hot burning coal into space and returning with cold ice.
It's like Millen. When he's angry, he's everywhere, so big. But when he's sad, he's too small and cute.
Is it? What about you then?
I'm always happy, not like you. Always happy.
I have 3 states: angry, sad, and happy. Not like you.
Like the 3 states of matter.
Yes, solid, liquid, and gas.
Right. Well, let's do another experiment, shall we? But this time, we need to be a little careful to not make the place messy, okay?
Oh, yes.
Let's do an experiment. That's how you'll see just what I meant.
Oh yes, I get to do something fun.
Oh yeah, and I get to know something cool. Yes, 'cause when you do it,
You get to know it.
Properties of solids. Take a big, smooth stone in the hand. Feel the stone. Squeeze and squash it with your hands. We cannot change the shape of the solid. Solids have their own shapes and have the property of being rigid. Quality and property of liquids. A jug of water, 4 transparent bottles of different shapes is what we need. Pour colored water into the 4 bottles. In the first bottle, it took the shape of a prism. In the second, it has taken the shape of the cylinder. In the third, the water has taken the shape of this prism. And in the fourth, it has taken a conical form. This shows that liquids don't have a shape of their own. They take the shape of the container that they are in. Now, spill a little water on the table. The water did not go up. It fell on the table and then flowed down. Liquids flow only sideways and downwards. Pour water into a bowl. Put your hands into the water. I can put my hands right into the water. Now try this with the stone. I cannot put my hands into the stone. Why? The particles of liquids do not cling tightly together, so we can put our hand in. The particles of solid cling tightly together, so we cannot put our hand into the stone. Properties of gases. Open a bottle of perfume at one end of the room. The perfume travels to all parts of the room. I open the bottle of perfume near the door, and now it has reached the entire room. How? We smell perfume because air can move and the particles of gas do not cling together at all. Gas can move in all directions, even upwards. Matter changes state at different temperatures. We need ice, tin piece, gas burner and pan, wax, and iron. Let the pan become very hot. Place the iron piece, tin piece, wax and ice on the hot pan. Watch to see what happens. The ice melts and evaporates first. Then wax melts and evaporates. Tin melts next. And iron remains as it is even after a long time. Iron did not melt as the heat was not enough to melt it. Tin, which is a solid, started to melt after a long time. The wax melted to a liquid and then became gas. The ice, which was a solid, melted to a liquid and then became a gas. Iron, which is a solid, remained a solid even on heating. Substances have different melting points and boiling points.
Oh, so in this way, different shapes and different planets were formed?
Yes, it took many light years to come to the shape. Now, the universe has many such groups of planets. We can compare them with families. It takes a lot of time to form a family. New members will be added and some members will be removed in the course of time.
So our family came after that?
Yes, our family too. It took so many years. As we saw, everything was hot and then it started cooling down. Human beings came millions of years later, Mia. Let's see how the cooling happened first, shall we? How marvelous it is and how simple. If you become hot, you expand. And as you expand, you soar upwards, like a bubble of air in water. But If you become cold, you shrink and fall, like a grain of sand sinking to the bottom of the pond. Because of this law, the earth gradually changed from a ball of fire to the earth we know. This was a law that the tiny radiant particles obeyed as they danced their dance. Particles too minute to be seen or imagined, but so numerous as to have produced our world. For hundreds of millions of years, this dance went on. Finally, the particles settled down like tired dancers, and one after another, they became first liquid and then solid, joining with others whom they were attracted to form new substances. The heavier ones went near to the heart of the earth, while the lighter ones floated above them like oil on water. A thin scum was formed on the earth, like the skin which forms on milk when it is boiled and left to cool. It seemed as if the earth had taken some shape, but the elements inside the earth still felt very hot and trapped inside. They wanted to get out. They had to follow the law given to them that if they are hot, they need to expand and spread out. There was no place to spread out, so they burst out, breaking the skin of the earth, causing a terrible fight. The water that formed on the surface turned immediately into vapor, and then the hot stuff came out from inside the earth. This made lots of smoke and ashes. A veil of cloud was drawn to cover the earth because the sun did not want to see all the fighting that was happening. This is what happened to our planet a long time ago. All the cracks on the Earth's surface created lava, burning ashes, boiling water, in which all types of mineral substances were dissolved. There was so much of water vapor, smell of chlorine and ammonia. These gases which escaped from the volcanoes surrounded the whole of the earth. In the beginning, the earth couldn't receive the rays of the sun, and the sun couldn't see the earth. Here is a piece of lava and a piece of pumice that are both produced by volcanoes. The lava is very heavy, and the pumice is really light and full of tiny bubbles.
I have seen volcanoes in movies. Are there any real ones still?
Yes, they're still there. In fact, there is something called the Ring of Fire, the region where you can find most of the volcanoes.
How can we see it?
We can't go there, but I can show you an experiment on how it happens.
That's cool.
No, that's hot.
Yeah, I know.
Let's do an experiment. That's how you'll see just what I meant.
Oh, yes. I get to do something fun.
Oh yeah, and I get to know something cool.
Yes, 'cause when you do it,
You get to know it.
Volcano. We need sulfur, matchstick, volcano model and ammonium dichromate. Pour 3 tablespoons of ammonium dichromate. Add 1 tablespoon of sulfur. Light fire to the things in the crater using a long matchstick. Smoke comes out and then sparks are seen. Well, inside the earth there are things that want to come out to the surface, and in this way They form volcanoes.
I can't imagine an Earth with so many volcanoes.
How did it all become like this?
Let's look into the book again. This is the earth on which we live. Remember, here is land and here is water. After thousands and thousands of years, the earth has cooled down. There are still some volcanoes, but few when compared to the early ones. The water filled the earth. The cloud that surrounded the earth dissolved and it disappeared. Now the earth could receive the rays of the sun. The earth has become beautiful, and we can see how the sun can smile on his daughter. This is what the earth looked like after cooling. If we could cut through the earth, we could see all the secrets she holds inside. All the red parts are made of heavy parts, metals, and around them there is a thin layer of rocks. Above the rocks is water, and above this is air. Heavier is at the center, and what is lighter is to the outside. So, they have all been obeying the laws given to them.
Obviously, it takes a lot of time to make such a big earth.
You think the earth is big? See this.
Whoa!
See, the earth is just like a dot when compared to the sun. The sun is million times bigger than earth.
Oh!
Million? Wow, the Earth is nothing in front of the sun.
We are nothing in this universe, in fact.
That is good to remember always. We are nothing in this huge universe.
But we are something.
Yes, there is something about.
Nothing. Oh dear, again in the dark, cold world? Grandma, are we starting the story again?
Oh, Milan, will you light a candle, please?
Yes, Grandma.
Happy birthday to you. Happy birthday to you. Happy birthday, dear Mia. Happy birthday to you. The earth still spins round and round itself and round the sun, as it did many millions of years ago. The earth and all the elements and compounds it is made up of, by doing their task continuously, are obeying the laws of nature.
Montessori grandma